Hello, my name is Joshua. Welcome to our series on artificial intelligence. In this series, we're going to talk about large language models, ChatGPT, and the various products that are coming to market built on top of this technology. Throughout this series, we are going to talk about the basic concepts of machine learning and LLMs. Now, before we jump into the key terms, I want to make a small disclaimer like any good lawyer would, and I want to say I don't profess to be any kind of true expert on artificial intelligence. I think to truly have a deep academic understanding of these technologies, you probably need 1 or 2 PhDs in some form of advanced math or engineering, but I can walk you through some of the basics and give you a working understanding of what these terms mean. All right, let's dive in and let's talk about some of the key terms. What is machine learning? Machine learning is a mathematical model, and it's a model that can learn from data and it can learn to make predictions and make decisions. What is natural language processing? Natural language processing is a form of artificial intelligence, and it allows you and computers to understand each other. So when you are typing with text or you're saying words in a way that other humans would understand, that allows you to communicate with the machine. If you say, "Hey Alexa, what was the score last night?" Alexa thinks about it for a second and says, "The Chicago Bulls won by 3. Well, that interaction where you're using words to talk to the machine and the machine is responding in words that are coherent and make sense to our ears, that is all powered by natural language processing. Now, the important thing here is that in the past handful of years, natural language processing has allowed these technologies to get better at understanding things like context, intent, and sentiment, which allows you to have a more natural, much more conversational style of communication with these technologies. What is a neural network? A neural network is made up of many, many layers. There is an input layer, then there's a bunch of hidden layers, and then at the very bottom, there is always an output layer. And what is happening is whatever input comes into the neural network, now this could be text, it could be spoken words, it could be audio, video, any number of things. Whatever is coming into the input layer, the neural network will take that input, grind it up into numbers, and then those numbers will filter through the layers of the neural network. And as the numbers filter through the layers of the neural network, the network is using a system of weights and biases and previous training to determine which of those numbers are more important and how those numbers are connected to each other. It then uses that information to figure out how the numbers might suggest the correct output, so that's the prediction part of the technology. And then at the very end, after it's gone through this filtering process, it spits out some form of output. So the main takeaway here is just to understand that whatever form of neural network you're dealing with, whatever form of technology that's built on this architecture, your input is always being ground up into numbers, filtering through layers of the neural network, and then being transformed into output like words, audio, an image, a video, and so on. It's this transformer architecture that powers much of the exciting new technology that we're using today. So that's what's going on in the background for this technology. What is a large language model? LLMs are a subset of machine learning models, and the main difference here is that large language models are trained on a much larger body of data than ever before. So historically, there was this idea that if you could train a model on a small amount of data and you could get that just right, then you could scale that up and it would be useful. But this actually proved to be really frustrating and really difficult to do. So there was a big shift in the philosophy around this technology, and the idea was, well, maybe instead of training the model on one book, what if we were to train the model on, say, every book that has ever been written? So that jump in the scale of training data and the size of the models has led to a lot of the breakthrough that we're seeing with new AI applications. That's it for this video. If you enjoyed this conversation, please tune in for the next one. We're going to dive into talking about training ChatGPT. We'll demystify what does it mean when we're talking about tokens and predictions and all that other stuff. And we'll talk about how ChatGPT learns and functions. Once again, my name is Joshua Weaver. I'm the director of the Texas Opportunity and Justice Incubator. TOJI is a flagship program of the State Bar of Texas, where we help attorneys launch and develop sustainable law practices serving underserved communities. Thanks for watching, and tune in for the next one.